Welcome everyone. Today I will talk on the effect of shape and orientation on the thermal performance of greenhouse in the Western USA. This research was conducted by the undergraduate student in my research group. This is very common statistics that by 2015 we will have 1.7 billion additional people, and we have to produce 70% more food to support that increased people on the planet. And also 70% world population will move to the urban area. As our agricultural land is decreasing due to industrialization and urbanization, we can see that the control environment agriculture is becoming more popular for increased production with a small footprint. And this expansion is relatively higher as compared to the open field. However, the control environment agricultural production facilities is very energy intensive, and we can see the energy use is very high in the Mediterranean climate like Iran, and also it could be it's very high in the cold climate like Canada. And the general statistics is that the energy used for the heating, cooling, and the lighting for control environment agricultural facilities could be up to 30%, even higher. Another statistics also showing that the greenhouse gas emission from the food supply chain is about 30%, and these numbers could be even higher when we have to produce more food and we have to use the control environment facilities, which is more energy intensive, and that could increase more greenhouse gas emission. I would like to share another statistics. This is kind of based on the response from the greenhouse grower, and it's showing that still like 50% of the industry is responding that they cannot make enough profit from their business. So therefore, like we have to focus on how we can kind of minimize the energy use to reduce the operational cost. The energy reduction could be minimized with the passive design, the design, the building envelope, building geometry, natural lighting, and the ventilation. And also we can reduce the dependency on the fossil fuel, like the integration of the renewable energy based system for the operation of the HVAC system. This study as will focus only on the shape and orientation. Previous studies have evaluated different types of the shape to analyze the thermal performance in different locations. For example, one of our previous studies, we found that in Canada, in Saskatchewan, the most efficient shape is the even span. In India, another study found that the uneven span is more efficient in terms of the energy use. And other study also recommend similar or kind of little bit different shape depending on the location. And we can see the orientation also has some impact in terms of the solar radiation availability that will impact on the energy use in the greenhouse. And this is for a different location, like at 50-degree northern latitude. And we can see the energy use could be different depending on the orientation, like east-west or north-south. Therefore, in these studies, we try to kind of analyze the heating and the cooling demand for different greenhouse shape. And in that aspect, we just consider two different scenarios, the closed greenhouse and the open greenhouse. And we selected 6 different shapes. And also the orientation like east-west for 0-degree surface azimuth, and the north-south with 90-degree surface azimuth with 15-degree increments for the rotation. For analysis the heating and the cooling demand, we have used one of the models that I developed during my PhD study. And that model can simulate the heating and cooling demand based on the input of the indoor environment, the thermal physical properties of the construction materials, and the weather data. So I will not explain about this model. So if you're interested, you can read this article, which is published in the journal. And these studies, we did some additional things like to develop a ventilation submodel, because the previous model need to input the constant the air turnover rate, and the model simulate based on that things. But in the relatively hot climate or the moderate climate, greenhouse usually practice the ventilation, and therefore we try to integrate a submodel to simulate the time-dependent air exchange rate into the greenhouse. And in that case, we commonly used the submodel that is very frequently used for greenhouse model to simulate the ventilation rate with respect to the opening angle of the vent. And then finally, we integrate that model with the GREENHEAT model, and that can simulate the heating and cooling demand based on the angle of the vent, and also the other input parameters like weather data and the constructional parameters like the thermal physical properties of the construction materials. And in this case, we selected 3 different locations in California, like the cold climate where the average temperature is 6 degrees Celsius, and the moderate climate with 15 degrees Celsius average temperature, and the imperial with 22 degrees Celsius average temperature. And this graph is showing the change of the temperature and relative and the solar radiation over the time. We can see in terms of the solar radiation is kind of very similar intensity for the Bridgeport and the Santa Rosa. And in Imperial, its intensity is significantly higher. This result is showing the impact of the shape on the solar irradiance available inside the greenhouse. We can see that all selected shape has kind of similar trend in 3 different locations. In terms of the intensity, the solar radiation in Imperial is relatively higher, which is about 21% higher compared to the Bridgeport. Then we also try to kind of analyze the impact for the closed and the ventilated greenhouse for 3 different locations. So the general trend is like for the closed greenhouse, the heating requirement is relatively lower for all 3 different locations. And in terms of the cooling, we can see in the Bridgeport, the cooling requirement is increased for the closed greenhouse. This is because of neglecting the benefit of the natural ventilation to cool down the temperature. But for the moderate and the hot climate, we can see the cooling demand is decreased for the closed greenhouse because of the high outdoor temperature. The allowing outside air will add the heating load to the greenhouse, and thereby the cooling demand will be higher. And the intensity is relatively high in Imperial, and we can see that the cooling demand in Bridgeport is 4% higher for the closed greenhouse, which is 2.4% less in Santa Rosa and 43% less in Imperial for the closed greenhouse. Then we also try to analyze the change of the heating and cooling demand over the year for the selected location. We can see that in Bridgeport, there are a significant amount of heating throughout the year. And the cooling demand is very high in the summertime. And in the wintertime, the cooling demand is slightly lower than the heating demand. So in terms of the total energy demand for the selected shape, we can see that the maximum energy is required for the uneven span shape, and the minimum energy is required for the coinset. And the even span and modified arc is the second and the third highest energy consumption. So in terms of the heating energy demand, we can see that in Bridgeport, the heating energy demand is about 27% of the total energy demand. The similar pattern we also found for the Santa Rosa, and definitely like the heating demand will decrease and the cooling demand will increase because of the outdoor climate. And the similar pattern we also found for the shape in terms of the total energy demand. And we can see the total energy heating energy demand is about 11% of the total energy demand. For Imperial, we can see the heating demand is negligible after the May and until November. And for other months, it's also very small amount of heating is required. And cooling demand is significantly higher throughout the year. In terms of the total energy demand, we also found the similar trend in terms of the shape. And we can see the heating demand is only about 2% in Imperial. Then we also try to analyze the orientation. So in that aspect, first we try to see the impact of the orientation in terms of the solar gain. We can see with the increase of the surface azimuth from 0 to 75 degree, we can see the solar heat gain is increased for all 3 different locations with same trend. And after that is slightly decreased. And similar pattern also we found for in terms of the total energy demand. So in that aspect, we can see the lowest energy demand in Bridgeport was found for 90-degree surface azimuth. However, for the Santa Rosa and Imperial, we found the 0-degree surface azimuth is more energy efficient. However, in general, this impact is kind of very small compared to the impact we found in the shape analysis. Finally, we can conclude that the energy required for cooling is significantly higher than the heating for most locations. And also the location had almost no impact on the shape. And the orientation also has very minimal impact on the energy demand. And in future, these studies could be extended to validate the model as we have integrated the sub-model with the GREENHEAT model. And there could be some economical and environmental analysis for growing crops in controlled environment in California and what is their economical and environmental benefit. And thank you, everyone. So I'd be happy to receive some question by email or during the question and answer session at the conference. Thank you.